So yes, we can spend some time going over a problem. I'm assuming 845 or?
845 and 849.
Okay. All right. Let's do 845 from last week's homework. Okay. And you know, I'm actually going to just modify this question a tiny bit so that it will kind of look like a question you might see next week on next week's quiz, okay? So basically, in problem 845 in the homework, it says, you know, we have a random experiment. To see if Vioxx users have a higher risk of heart attack than the placebo users. Okay, and let's just go through the data here. The data, we have Vioxx users. And how many people total do we have for Vioxx users? So I'm going to do N with a subscript V so we know that we're talking about Vioxx users. It says there was 1,287 people taking Vioxx. Okay? And then I'm going to put an X for those who had a heart attack. For the Vioxx users, there was 45 people. Then we have placebo users. So the number for the placebo, it says 1,299, and the people who had heart attacks under placebo, there were 25 people, okay? And so we want to know, is this difference significant, okay? So partly we should, we're going to have to do some more calculations here, but the question is, the statement says, perform a test to see, perform a hypothesis test to test whether those who take Vioxx have a greater rate of heart attack than those who take placebo. Okay, perform a test to see if those who take Vioxx have a greater rate of heart attack than those with placebo. Okay. So the very first thing we should do is create our hypotheses. Okay. So I've just rewritten our question into this form. And actually, so to align it with the types of questions you might see on next week's quiz, you might have a setup similar to this, and maybe I won't have the numbers nicely labeled like this. It might be written as the paragraph. But I will say, okay, given this problem, I want you to write the hypotheses. Okay. And then I might say find P hat of Vioxx, find P hat for placebo, and find the difference between P hats. And then I will also say find the overall P hat. So find the standard error, find the test statistic. These are all steps that you need to be doing. find the p-value, make a conclusion. Make a conclusion here. Okay. So these are all steps that you need to do when answering this type of question here. Okay. So I'll give you guys a second to copy this down. Okay. So this is just everything that's coming from problem 845. All I've done is I've read the problem and I labeled the numbers given in the problem as n and x. Okay. And I advise you guys do the same whenever you come across a problem like this in your homework or on a quiz or something like that. Okay, let me just save this. I advise you label your numbers in whenever you're coming across, whenever you do a problem like this. Okay. Okay, so let's go through the answer here. Okay. Is it all right if I clear this screen? Just a second. Let me just. Okay, now I'm going to clear. Huh? Okay, here we go. And let me just shrink this. All right, so what I need to do. Okay, so part A says write our hypotheses. Okay. So the null hypothesis. Okay, how many samples do we have? We have 2 samples, and we're dealing with proportions, right? So I said the null hypothesis is always going to be what? P1 is equal to P2, okay? Or in this case, because we've got Vioxx users, I'm going to put P Vioxx is equal to P placebo, okay? Or equivalently, you could just write P1 is equal to P2. That's also the same. Okay. And then the alternative, when we read the problem, okay, it's going to still be P Vioxx versus P placebo, but now we want to know, do we use greater than, less than, or not equal to? Okay, the null hypothesis always has an equal sign. The alternative is going to have what? Okay, when you read your the question, it says perform a test to see if those who take Vioxx have a greater rate of heart attack. So what we are asking is P of Vioxx, those who have heart attacks for Vioxx, is that greater than the rate of heart attacks for placebo users? So this is going to be our hypotheses. Okay. And you'll notice that these statements here align with statement I in the textbook, and this one aligns with statement II, or statement 2. Okay. Is that okay with everyone? Okay, so then let's find P Vioxx, P placebo, and then the observed difference. Okay, so P Vioxx is 45 divided by 1287, and P placebo is going to be 25 divided by 1299. Okay, and then the difference is going to be PV minus P placebo Okay, and so we're going to have all sorts of fractions and decimals here. Okay, so I have 45. Oh, you know what? Let me set up. Okay, so I have 45 over 1287. Okay, 0.03497. And over here, I have 25 over 1299. Okay, 0.01925. And so a lot of you guys ask, how many decimals do I need to keep? All of this. I actually don't, when I do my calculator work, I leave everything in kind of fractional form here. So I do 45 divided by 1287 minus 25 divided by 1299, and then I get 0.01572. Okay, so this is my observed difference right here. Okay, so this is P Vioxx minus P placebo. Okay, or if you labeled them P1 and P2, P1 hat and P2 hat, that's also fine. Okay, P hat overall is going to be x1 plus x2, or x Vioxx x placebo divided by n1 plus n2. So here I have 45 plus 25 divided by 1287 plus 1299. Okay? Be sure you add the numerators first and then add up the denominators. Do not do the two fractions separately, and then use that. So 2586 70 divided by this 0.0271. Okay, this is my P hat. The standard error for our next step is given by P hat times 1 minus P hat times 1 over n1 plus 1 over n2. Okay? So I'm going to use 0.0271 times 1 minus 0.0271 times 1 over 1287 plus 1 over 1299, and I take the square root of everything here. Okay? Notice in my calculator, I already have 0.0271 in my screen. This is going to be my, whenever I hit answer, it's going to basically pull up this number here. Okay? So I'm going to do this calculation just by using the answer key. So I'm going to do answer times parentheses 1 minus the answer, because whenever I put an answer, I've got that number, times 1 over 1287 plus 1 over 1299. Okay, and then I hit enter. That's going to give me everything that's inside the square root. It's this tiny little number here. But I'm going to take the square root of that and hit square root of the answer. And I get 0.00638. Okay, so my standard error is 0.00638. Okay. Okay. And now we want to find our test statistic, which is our z-score. Okay? So the z-score is going to be the P1 hat minus P2 hat divided by our standard error. Okay? So I could use 0.0271. That's what we know that's, I'm sorry, not that, 0.01572. Basically, that, I'm going to just say that this part right here is something that we've already found, which is this part right here, okay? So this is essentially 0.01572 divided by this number right here, the standard error, 0.00638, okay? So I'm going to do 0.01572 divided by, and 00638 is already in my answer key, so I hit that, and I get 2.46 is my z-score. This is my z-score. Z is equal to 2.46. So part F then asks us to find the p-value. Okay. So when we're looking for the p-value, I'm going to look at 2.46, and because the question says, what is the probability, or not what's the probability, but perform a test to see if the proportion of Vioxx users has a proportion or greater risk of heart attack. I'm going greater means to the right, so I want to find the area to the right of 2.46. Okay, and so for that, I go to my Z table, and I'm going to look up 2.46, and the number I find is 0.9931 right here. Okay. So the area to the left, so from the table, area to the left of 2.46 is 0.9931. So the area that I'm looking for is 1 minus 0.9931, and I get 0.0069. So this is my p-value. Okay. Do you guys get this in your homework? A little bit? Okay. All right. Now this is the most important part, okay? So you did all of this work and you finally arrive at this p-value, okay? The key part, did everyone get this copied down? No? Okay. I hope you guys are able to at least follow these steps that I've walked through here. Okay. And I would study this, okay? Because you're going to see a question similar to this. Of course, it's not going to be Vioxx and placebo users, and the numbers are going to be different, but it will be very similar in terms of this nature and this setup here, okay? So you should be able to set up your hypotheses, figure out your proportions from your samples, and find the observed difference between those proportions, find your overall p-hat, find your standard error, find your test statistic, and find your p-value. Okay? These are all things that you need to do when you're dealing with this kind of problem. Okay? And the last part, making your conclusion, is perhaps the most important part. So just remember that so far, the part that we have is that our p-value is 0.0069. Okay, so maybe I will I'll copy this into our next slide. Okay. Move that over here. Okay, so our p-value is 0.0069. Okay? And so what we should notice is that our p-value is small. Okay? Let's say if alpha is 0.05, which is our most common value of alpha, the p-value is less than alpha. And so whenever your p-value is less than alpha, the conclusion or decision is to reject the null hypothesis. Okay? What was the null hypothesis? If you go back, the null hypothesis was that PV is equal to PP. So that means the rate of heart attack for Vioxx users is the same as the rate of heart attacks for placebo users. The alternative was that P Vioxx was greater than P of the placebo. Okay? So if we've rejected the null, that means we have evidence that the rate of heart attacks for Vioxx users is not the same as the rate of heart attacks for placebo users. Okay. And actually, we have evidence that the heart attack rate for Vioxx users is higher than placebo users. Okay. Higher for Vioxx users than for placebo users. Okay. So if you just want the short summary, okay, the things you want to hit are the p-value is less than alpha, reject the null, we have evidence that rate of heart attack is higher for Vioxx users. Okay. These conclusions are very important. If your p-value is less than alpha, you reject the null. If your p-value is greater than alpha, do not reject the null. Those are the two key decisions that you need to make. You have to decide one or the other, and then the interpretation is if you've rejected the null, you have evidence to support whatever the alternative says, and if you didn't reject the null, then you don't have evidence to support the alternative. Yes, question?
So on the quiz, will we be writing out this much work?
I would imagine so. I would imagine, yes. Okay. So
are you going to give us like extra room to do this kind of work?
you'll have a full page for probably one of these problems here, okay? And I'll list off, A, B, C, D, E, F, or whatever. And you have to do each of these things, and then I expect to see this kind of stuff. So study this, okay? I can't make it any more clear what kind of questions I'm going to be asking next week, okay? Nobody next week should be like, oh my gosh, I wasn't expecting this, okay? I'm telling you, this is what you're going to see. It's not going to say Vioxx and placebo. It's going to say something else, of course. But, okay, you can do this, all right? You even get a note card. Just copy this down on your note card, right? there's no excuse to do poorly on this quiz, but historically, quiz 4 is like the worst scoring quiz. So I don't know what I can do. I'm trying, you guys, to help you. You please don't break my heart here. Yes. Anyway.
So, Professor, whenever p is less than alpha, we always reject the null.
If your p-value is less than alpha, reject the null. Okay. Now, keep in mind this is your p-value, which is the number you get after you look it up in the reference table. Okay. It's not the proportion. So some people get confused and say, oh, well, I got my proportion. This is a p. That's my p-value. That's not your p-value. Your p-value, you have to go through all of the steps. You look up your test statistic, your z-score, or today you're going to do a t-score in your table, and the resulting number you get there is your p-value. Okay? Yes?
If alpha is not given, should we generally assume 0.5?
Yeah, if alpha is not stated, assume alpha is 0.05. Okay? The problem might state to use a different alpha, but if it's not stated, assume that it's 5%.
Is that 0.05?
Yeah, 0.05, 5%. Okay, some of you guys came in late. If you came in late, you need to get one of these two tables. Okay? And let me, I'm going to actually pause the video here so you can just watch the